Hello and welcome back to my series on Mastering GenAI with MLflow. This is the episode 8, and in this particular episode we're going to concentrate on prompt optimization with GEPA, which stands for Genetic Pareto Technique, whereby we automatically optimize a prompt to get us the best prompt for the best outcome. Now, in episode number 5, we talked about prompt management and how we can actually use the prompt registry to create different versions of the prompt, assign different aliases to the prompt, and then use those aliases to either seamlessly move from staging to production and back from production to staging. That was a good introduction to how we can actually use prompt management. This episode takes you a little further to say, what about you wanted to optimize a particular prompt? In the previous version, we kind of explored, you try version number 1, that didn't work a little bit, you try version number 2, and you kept on doing it. Now, humans are not really scalable in terms of creating different versions of the prompt. It takes a lot of effort. And so this is a good way to take a baseline prompt and optimize it. So we find out in this particular episode how we can actually use this GEPA technique in a very short video. So let's go ahead and get started. In this video, we're going to talk about, and you're going to learn about automatic optimization using GEPA. We'll use the prompt registry as usual, because prompt registry allows us to create different versions of the prompt, and the optimized version will just be a different version that we can actually use. And then we'll look at how we can actually look at the before and the after scenario with baseline prompt that gives us a very bad result, and an improved prompt after GEPA optimization that gives a stark difference between the before and after scenario. So basically, you will learn how to use this particular technique automatically with the help of MLflow integrated API called MLflow GenAI optimized prompts. We'll use a custom scorer for a quick, fast match. This is one of the techniques, but you can use other scorers such as LLM to be able to actually match your output. And then we'll compare the results. And basically how GEPA works is very simple. There are 5 steps involved in that. It's like a repetitive loop. You got evaluate, which actually runs the particular prompt on your training samples, and we'll see how you can actually generate those training samples, and score with a judge. You can reflect on that. Now, you use LLM to analyze the failures and the proposed improvements. And once that's actually done, we improve the particular prompt and then select the best problem candidate using the Pareto optimal technique. And then finally, we repeat this particular process until our budget is exhausted. Now, budget here does not mean the dollar signs or the number of tokens. Budget here is similar to the number of iterations, the number of epochs that you actually run. Something very similar if you're coming from the data science background. When you're using gradient descent, you have a number of epochs that actually run, or when the convergence happens and it reaches your maximum output, which means now you actually can get out of the loop. So that's sort of a very basic technique. And as we explored in 105 manual, we did the human way of evaluating or improvement prompt. And that's really a high effort, and it's not really consistent because our language capabilities can vary from one prompt to the other one. Whereas with the GEPA and this particular notebook you require, we use an algorithm to actually evolve the prompts. And that's a low effort because it's more systematic, it's more incremental way to do it, and it's more efficient way to do that. So we'll see how we can actually do that. Okay, so I ran this particular notebook because running the optimization can take a long time depending on the number of samples you have. So for brevity and for the illustration, I run this earlier and I kept the samples very easy for us to see the difference. So I run my setup. I'm going to use my client GPT-5 because it's a smaller model and, we can take a long time. So we just want to make sure that we don't burn our tokens. I'll create my experiment. So I'm using my OpenAI provider as before with all my experiments. I'm creating a local experiment host, tracking server, and I'm going to go ahead and create my baseline prompt. Now, this is where the key thing comes in. You create your baseline prompt, which is where you start working on optimizing it. And my baseline prompt, I name it as HotpotQA simple. And my baseline prompt is very generic. Answer this question given this particular query. Now, there's no instructions to it. There is no format. How do I want? What do I expect? But that's our baseline. And then we're just going to have a commit message as we explored in our previous way, how you actually manage and register things in the prompt registry. And that's our prompt initially registered as version 1 in our prompt. So here we have our output from the register. We have the name, the version, and the prompt URI, how we can actually load that if you actually wanted to do that. And then we're going to create our training data set, a scorer and a predict function. So the GEPA actually needs those three things. It needs a training set, example of input and output, so it can actually evaluate when we actually looking at the quality, whether the expected answer was similar to what we were expecting. A scorer, and scorer is normally a judge, a function that scores how well the output matches with the expectations. And then finally the predict function, and the predict function is normally a callable Python function that leads the prompt from the registry that you actually have registered and fills in using the template its variables and then calls the LLM to get the answer. For this particular tutorial, the design strategy is very simple. We're going to use a short answer exact match. And we use this short answer exact match to sort of get the inspiration from a benchmark called HotpotQA optimization benchmark. And so we use sample of that to be able to actually run through this rather quickly, rather than actually having a very generic and very a long prompt that could take, anywhere from 15 to 20 minutes. So this makes it a lot easier. Why this works is because, what you actually want is when you actually send a request in this particular sample, you don't want an entire output to say, well, what is the capital of Japan? We actually want just one letter word called Tokyo. But normally when you give that particular query to an LLM, it's going to give you a very verbose long answer. And our exact match is, I just want one answer, and that could be either 1 or 2 words. And the reason why this works very fast in this exact match is that it's a pure Python function that just does a string comparison. There's no LLM involved. Whereas normally if you actually had a more nuanced prompt and you required natural language to be able to actually assess that, then you would actually have an LLM call. And normally when you have 2 LLM calls for each iteration, this can get a bit expensive, but that's the way it is, how GEPA actually works. It does give you the best prompt, no matter the cost. But it's a good way to actually use that. Okay, so I have my prompt, I have my scorer over here. As we saw in our previous episode on expectations, you can actually write your own custom scorer by tagging your function with the operator. So I have my decorator kill scorer, and it's an exact match. Given the output from the LLM and given the expectations that I have from my input set, I'm going to compare whether the actual answer is exactly the one that I've expected. And if the answer is yes, we're going to go give a categorical feedback. Yes. If the answer is no, then we're going to use this particular object called categorical rating as no. And then here's my training set, very simple training set that actually has a question, and the expectation has the expected response to be either single word or no more than 2 words. So this is our training set that we're going to feed into GEPA that will iterate over the prompt, and every version of the prompt, it will improve to see how we can actually get the exact match. So here's my predict function now, which actually just takes the question, sends it to the LLM that we actually used as a judge to query that and get the response, and then compares the response with the predict function. So I define my training set over here. It's prepared by short answers. I have a custom exact match score defined. No LLM calls are involved, so it's a little quicker and faster and less expensive. And he loads the prompt from the prompt registry. So let's see how we can actually run this particular GEPA optimization using the MLflow API. We're going to evaluate the baseline using the exact match as our matcher. We'll reflect that depending on what the response was written by LLM against the verbose answer, and it will iterate to the next version to say, well, I really don't want a verbose answer, I want a shortened answer. And it'll repeat itself till it actually gets the exact match. And then at that point, we have converged, we have aligned. Our scorer says these responses are coming back well with the prompt that we iterated over, and we are done. So let's go ahead and do that. This might take anywhere from a couple of minutes to 10 minutes, depending on the number of samples that you have, and depending whether you're actually using an LLM jump for both cases, asking the judge to give you an answer and also evaluating using the scorer. So here we're going to actually run this particular GEPA optimization. API is very simple. We're going to use optimize prompt, which is integrated as part of the MLflow. We're going to give a predict function. Here we actually have a training data that we actually give, and then our baseline prompt, which we already registered as very simple, answer this particular question. And then we're going to use this particular class called GEPA Prompt Optimization. And it takes few arguments, name value arguments. One is the optimizer model. And the optimizer model is the one that's going to judge how well the particular output was. And this over here, we actually use an optimized model to be GPT mini. You can actually use any one of those. Max metric calls is an argument which tells you the budget. This is something very similar to epochs. I want to use 100 calls, my iterations. And then I have my display progress to be full. You can actually have your bar progress. And this is an important bit. This is the important part where we're actually saying that this is kind of very similar to gradient descent, where we're doing early stopping, where if you don't see the conversions difference from the previous 3 or 4 runs, then I want you to early stop, which means that I either done it or nothing. I don't see any improvement. So over here, we're going to do max iterations without any improvement to be 3. In other words, if my previous 3 iterations didn't give me any delta increments in conversions to the answer or to the exact expectations, at this point, I have pretty much either reached my maxima or something is wrong, so I'm going to do early stopping rather than burning entire budget. And then I provide my scorers to be the exact match. So that is somehow the essence of how you actually use GEPA. And once this particular thing run, it'll actually run for about a few minutes. As you can see, this is my run that's actually running. And it's going through the first iteration where it's taking the base program. And we got a very low score of 0.1 over 10 samples. And it keeps on doing it till it reaches a point where we actually get a good score. So for example, in the iteration 3, we actually got a perfect score of 1, which means that it aligned itself. And at this point, it actually skipped that because we have actually reached our maximum, so to speak. And then it actually registers the most recent or the most optimized prompt with the registry, and we'll see what it is. So if you actually look at this particular run, we burnt about 3,000 tokens. Yeah, it cost us about, less than 0.1 cent, and the latency was 25 seconds. So this, within half a minute, we were actually able to actually run that. And if you look at the output, we can actually go over here and we can go to we run about 36 traces. The token count was about 20K. This is how much it actually cost us using. This was the cost over time. But the important bit is when we go to the prompt registry, we actually get our different versions of the prompt. So this was our initial version, which was very basic, and this was the most optimized one that you can actually see. It's quite elaborate, and it actually also gives you the few short examples, how it's expecting output, what are the things that you shouldn't do, what are the things it's expecting. So this is quite an elaborate prompt, and this is the behavior that it's going to use going forward. So we got a very optimized particular prompt. And if I went ahead and I compared my original prompt versus the optimized prompt, you can actually see the huge difference between the runs. My initial score was 0.1, which is very low. My final score was 1.0, which means that I got a perfect score. It actually matched, and my improvement was about 90% improvement from the previous to the final optimized version. Here is my original prompt, and here is my optimized prompt using GEPA. So this essentially was a very quick way and a quick illustration that you can use, how you can actually use GEPA within MLflow to optimize your prompt by using a baseline prompt. So in summary, what we did over here was we used GEPA, which is genetic Pareto algorithmic to optimize prompts through this repetition called evaluate, reflect, mutate cycles. We use the MLflow GenAI for prompts, which is a built-in function integrated. And we use Prompt Registry to register both the baseline and the registered prompt. In this particular case, we actually use a customized scorer function to do the exact match from what it was written by the LLM and what we were expecting. And then we implemented what we call no improvement stopper strategy, which is like an early stopping. So if my conversions is not changing any with number of iterations, then I want to do some early stopping. And then we did the compare and after to see how the quality was improved from the baseline to the optimized version, and we actually saw a 90% improvement in the start. So key takeaway over here is that score design actually matters depending on what judge you actually use to score your difference, and it gives you the gap between the base prompt and the optimized one. You can use custom scorers because they're fast, they're Pythonic functions, so there's no LLM involved. And Custom scorers in this particular instance are normally used when you actually have an exact match or you have a factual data that you actually want to compare. But if you have something that's more nuanced, that you actually want the semantic equivalent, then you would have to use more a built-in judge or some other judge that gives you the ability to say, yes, this answer somehow semantically is very similar to what is expectation. And we use registry for our integration for using both the versioning and the final version. And then we combined the GEPA for the optimization fine-tuning using all the parameters necessary. So I hope you actually learned something, how you can use GEPA, and then join me for the next episode where we'll cover complete reg application. Thank you.